Number 11, write a brief description or definition of each of the following. And then we have those pesky gamma rays. So this isn't classified. This isn't called a Y ray. That Y is called a gamma. Now this is gamma versus a Y because this is coming from the Greek alphabet, right? Greek alphabet starts off with alpha, so this little beautiful letter, and then comes beta as the B, right? So this would be A, B. So this is beta. And then it kind of goes off course where we have the Y, aka a gamma, but we have a C. So ABC, alpha, beta, gamma. I am 95% certain that gamma is the third letter of the alphabet, but I could be mistaken. If I am, please let me know in the comments, but I'm pretty sure that it's alpha, beta, gamma, and that's why it's alpha, beta, gamma, because it's A, B, C. But, always double check. We're always open for, comments, so let me know. All right, so I'm just going to, get rid of this. Whee! And let's talk about the gamma ray. Now, a gamma ray is not necessarily a subatomic particle. So gamma rays are not subatomic particles. Subatomic particles because they are they don't have any mass, right? And they don't have an atomic number. These are these gamma rays, when you talk about gamma rays, they are deleterious, SAT word. They are destructive types of energy for humans. And if you've heard of gamma rays, usually gamma rays come from something that's very catastrophic. So there was tons of radiation, which is, what gamma rays produce. They produce, terrible radiation. Gamma rays were produced during the Chernobyl nuclear power plant disaster, as well as the Fukushima nuclear power plant disaster. So some types of crazy nuclear reactions can produce these unfortunate, high energy. That's basically what these are. This is a very high energy, very, very, very high energy electromagnetic. It's on the electromagnetic spectrum. Radiation. Now, how are gamma rays produced? It's when you have matter clashing together with something called antimatter. Now, for example, right, and then you'll produce out these gamma rays. Now, the most popular one is when you have an electron, a normal electron, which is usually just denoted as an E, or you could say the B, the beta, because a beta is a electron, but we'll just say electrons. Normal electrons have no atomic mass on the top, but it has a -1 charge. And the antimatter is something that is opposite. That's what anti is. Anti means opposite of the matter that was given. So if this is a beta particle, right, or an electron, you want to counteract it with its antimatter, which would be a 0 on the top, but not a -1. It would be a +1. And this specifically is a positron. So you have an electron, or you could say that this is a beta particle coming together with a positron. You have its matter with its antimatter. And when those two come together, you form something that has 0 on the top, and -1 + 1 is a 0 on the bottom. So it's nothing to do with any matter, right? Because you literally have no matter anymore, right? Radiation. And that's what a gamma ray is. And in this case, you produce 2 of them. So it gets transferred over. Gamma ray. And gamma rays are very deleterious. They're very destructive. They will go through human skin. I don't want to make this any sadder than what this is beyond the chemistry context. But for those unfortunate situations in our history, when those power plants broke and the gamma rays were in the atmosphere, and those unfortunate firefighters and emergency personnel that arrived on the scene, unfortunate, they received so many gamma rays through their bodies, and gamma rays will go through the entire body. That's why they are very, 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 very high energy. They have the shortest wavelengths. They have the highest frequencies. They're so penetrating, that they will enter the body, and unfortunately, they cause mutations, genetic mutations, and it's just not good. But that's what a gamma ray is. So these will only come about in high amounts when stuff like the power plant bursting, and you have those type of nuclear reactions. These are not the same as X-rays. So gamma rays and what you get as an X-ray is not the same thing. So I hope this helped, though. But ultimately, what a gamma ray is very, very high energy, low wavelength, high frequency type of radiation, electromagnetic. It's on the electromagnetic spectrum, but you're not dealing with any types of matter anymore. It's all about radiation energy, because gamma rays have no mass, no atomic number. It's just a gamma ray. So I hope that helped. Thank you so much for viewing the video. Subscribe to the channel, and hopefully in future lessons we'll have a more upbeat video. But talking about gamma rays, it's just, but we have to know about our history to move forward. So thank you so much, and I will talk to you in the future. Okay. All right. Have a great, great, great day, and yeah, see you then. Bye bye.